Okay, so section 5.4, we actually look at the exponential function. Specifically, e to the x. We get into bases that aren't e in the next lesson, and we look at the derivative and the integral in one section. So the first day, we'll look specifically at the derivative of e. Very simple derivative. The derivative of e to the x is itself. Now, as with everything, we know that the exponent isn't only going to be a single x, so the derivative of e raised to the u power would be itself times the derivative of the exponent. So the derivative of the function e to the x always has itself in its derivative, and then we multiply by whatever the derivative of the exponent is. So let me continue to remind you. In addition to power, chain, product, quotient, trig, implicit, natural log. Okay, we have all these derivative rules. Now we're adding another one to it. Alright, so find the derivative of each. And we just do a bunch of examples. That's why I didn't put notes on Edmodo. Y equals e to the negative 5x. So y prime is itself times the derivative of the exponent. Derivative of negative 5x is just negative 5. So cleaning up the answer a little bit. That's our derivative. F of x equals 3e raised to the 1 minus x squared power. So the derivative, 3 is just a coefficient that stays with the derivative. Derivative of e is itself times the derivative of the exponent. So using the power rule, the derivative of 1 minus x squared is negative 2x. So negative 6x e to the 1 minus x squared. We generally write the exponential function last when we do the multiplying, put all the terms together. Y equals x squared e to the negative x. So I need my product rule here because I have one function in terms of x and I'm multiplying it by another function in terms of x. So product rule first times the derivative of the second. Derivative of e to the negative x is itself times the derivative of the exponent, which is negative 1, plus second times the derivative of the first, using the power rule, would be 2x. Now, for these answers, you should get in the habit of both terms have e to the negative x in it, because the derivative of e always involves itself. So you should get in the habit of factoring that out, and then we would write the final answer for the derivative in factored form. Alright, g of t equals e to the negative 3 divided by t squared. So I'm going to rewrite this first to be negative 3 t to the negative second power. So I'll write my exponent as a power, so we can use our power rule. G prime of t is itself times the derivative of the exponent. So using the power rule, positive 6 t to the negative third power, and now just making all my exponents positive. So I have 6e to the negative 3 over t squared divided by t cubed. And that's a 6, not a b. Alright, y equals natural log of 1 plus e to the x divided by 1 minus e to the x. So I'm going to rewrite my function before I attempt a derivative. I know that I can split this up into the natural log of the numerator minus the natural log of the denominator. Oops. So 1 minus e to the x. Now I can use my derivative of the natural log. 1 over the expression times the derivative of the expression. minus 1 over the expression times the derivative of the expression. The derivative of 1 minus e to the x would be negative e to the x. Okay, the derivative of 1 is 0. We have to keep the sign, and then the derivative of e to the x is just itself. Both terms have an e to the x. I'm going to factor that out. I'd be left with 1 over 1 plus e to the x. The two negatives cancel to a positive, plus 1 over 1 minus e to the x. And for right now, we'll leave our derivative in that form. Y equals natural log of e to the x. Alright, so the derivative would be 1 over the expression times the derivative of the expression. So that's just 1. So let's talk about a property here. ln of a to the n. We know that that exponent comes out front. Alright, that's our one rule we looked at. So when the base is e, it's a very specific use of the rule. So bring the exponent out front times the natural log of e. The natural log of e is 1. So this function actually just simplifies to x. What do we know? What's the derivative of x? Just 1. So again, these properties of logarithms, exponential functions, they begin to help us simplify the function before we even take the derivative. Now, did you have to see this first to find the correct derivative? No. But this property will become very useful next lesson when we integrate. Okay. Big F of x is defined as the integral from 0 e to the 2x, natural log of t plus 1 dt. Alright, so we're defining the antiderivative as whatever this antiderivative would be. You can't do this by hand. You can't integrate the natural log function. So using the second fundamental theorem, replace and multiply by the derivative of the boundary. So times e to the 2x, and then the derivative of the exponent is 2. So 2 e to the 2x, natural log of e to the x plus 1 would be our final answer. Alright, find the equation of the line tangent to the function y equals e to the negative 2x plus x squared at the point 2, 1. Equation of a tangent line, so y minus y1 equals our slope times x minus x1. The slope is going to come from the value of the derivative at the x coordinate given. So now let's find our derivative. The derivative of e is itself times the derivative of the exponent, so times negative 2 plus 2x. Evaluating the derivative when x equals 2, we get e to the negative 4 plus 4 times negative 2 plus 4. Anything to the 0 power is 1, so our slope simplifies nicely to positive 2. Alright, e raised to the xy power plus x squared minus y squared equals 10. Same directions, still find the derivative. My function's written in terms of x and y, so when we derive this, we'll need our implicit steps. Okay, so derivative of e raised to any power is itself times the derivative of the exponent. First times the derivative of the second plus second times the derivative of the first. Derivative of x squared is 2x. Derivative of y squared is 2y dy dx. Derivative of 10 is just 0. Now we do need to distribute the e to the xy because we have to get it away from the dy dx term. So x e to the xy times dy dx plus y e to the xy plus 2x minus 2y times dy dx equals 0. I'm going to move the dy dx terms to the right-hand side. So I'm going to keep the non-dy dx terms on the left. So adding the 2y, subtracting the x e to the xy, and factoring out in one step. And then I solve for dy dx, dividing by 2y minus xe to the xy. Now, if you move the non-dy dx terms to the right-hand side, this answer would just be the exact opposite, and that would still be correct if you want to try it the other way. Okay. So remember, this notation is for the second derivative. G of x equals square root of x plus e to the x ln of x. It's an x, not a y. Okay, so product rule on the second term, because it's e to the x times ln of x. Power rule on the first. So our first derivative, 1/2 x to the negative 1/2 power, plus first function times the derivative of the second, plus second times the derivative of the first. And because we need the second derivative, I would suggest leaving it in this form. Don't simplify anything, don't factor, don't make exponents positive, because we just have to derive again. So applying the power rule again, negative 1/4 x, subtract 1, you get negative 3/2. Now here we need the quotient rule to derive. So this is e to the x divided by x. Bottom times the derivative of the top function minus top function times the derivative of the bottom, all over bottom squared, plus, now we need the product rule again here. First times the derivative of the second, plus second times the derivative of the first. Okay, so simplify positive exponents. Next, I'm going to write the e to the x times the ln of x. And now let's just look at these two functions, because we can very simply get a common denominator. So common denominator of x squared, I would have x e to the x minus e to the x plus x e to the x. So this one stays as is. Now, what can we factor out here? We can factor an e to the x out of every term. That would leave me with 2x's minus 1 all over x squared. And then you don't need a common denominator from here. So we can keep this as the final answer for the second derivative. Alright, so for homework, f of x equals x e to the negative x. Attempt to find any extrema and points of inflection. If you can't actually find extrema and points of inflection, at least come to class with the first and the second derivatives completed.